So we'll take example of you can say this is BeCl2, first one, okay, then BeCl2. Here beryllium, the central atom, okay, it is bonded to the number of chlorine atom bonded is 2, number of 2, that means your number of sigma bonds is 2, okay, and beryllium does not have any lone pair on it, okay, because beryllium, see what is the valency of beryllium, it is 1s2 2s2. So when 2 is bonded with chlorine, there is no more lone pair, so it is 2. Hence this is sp hybridized, and hence it is linear. Okay, so if you go for beryllium, okay, this will be this, it will be showing lobes this way. Okay, this is your chlorine atom. Okay, there is another chlorine atom. Okay, it will be like this. Now, okay, so this is linear. Now number 2, we will go with BeCl3. Now see, again beryllium, you know, it is 1s2 2s2 because its total valency is 4. Okay, again so the outermost orbitals are these only. So what will this beryllium do? Again it will bond here with 3 chlorine atoms. Okay, now if it bonds, that means the sigma bonds, number of sigma bonds is again hybridization is nothing but number of sigma bonds, that is your 3, and number of lone pairs in beryllium is 0 because there is no lone pair, it will be the one charge will be there, so it will be your, now it is 3. So if it is 3, then it is sp2, and hence this will be your trigonal planar. Okay, so now this beryllium we will be showing like this 1Cl. Okay, so it will be showing you this way. Why P? Because see the chlorine one, the chlorine atom, because it is the chlorine valency is more, so the p orbital of chlorine actually gets into hybridization. Okay, so and s orbital of beryllium, so that's why it is sp3, and hence trigonal planar. Now we will go for the third example, that is again your methane. You know, methane carbon, last time also I told it is this shape. Why? Because it is your 3 sigma bonds, and hence it is sp3, and hence sp3 means tetrahedral. These things you have to remember. Okay, tetrahedral shape. Now we'll go for number 4 example is your pf5, phosphorus. What is phosphorus? Phosphorus comes in, what is the valency? Its total I mean it the atomic number is 15. Okay, 15, so it is 1s2 2s2 2p6 6 7 8 9 10, again 3d 2p6 3s2 3d 3d 3. Okay, 3d 3. Now phosphorus, like see, now it is last these two is there for hybridization, so that means it has 5 electrons, 1 2 3 4 1 2 3 4 5, because 3d has 5 and 3s. Okay, this is 2 electrons, 1 2 and 3. Sorry, it is 3p 3 sorry 3p3, sorry, it is this. Okay, so basically the thing is there are these many electrons, I mean 3 electrons. Okay, so this is your ground state phosphorus. Okay, phosphorus in ground state, and now we will go for phosphorus in excited state. If we go, it is like this, see, check. Okay, if we go for excited state, what happens is that this electron will go to the 3d subshells, 1 2 3 4, this will go like this. Okay, so now what happens is sp d. So how many fluorine atom is there? So 1 fluorine, 2 fluorine, there are 5 fluorines, So the total number of bond pair is actually 5. There is no lone pair, and hence it is going for sp3d hybridization. Okay, hence your shape will be trigonal bipyramidal. Bipyramidal. Okay, how? Check this. This will be the structure of chlorine. Okay, it is 1, 2, 3, 4, and 5. Okay, so this will be the structure. So hence it is trigonal bipyramidal. Is it not that it is looking like a pyramid in 3D type if you go? Okay, so this will be the shape in case of PF5. Now the molecule is your SF6. Okay, now we will see this is sulfur, SF6. So now sulfur, you know, it is 16. I mean the atomic number is 16. So 1s2, 2s2, 2p6, 3s2, 3p, 3p4. Okay, okay, now sulfur in ground state, we will, if we draw the orbital representation, it is like this. Sulfur, this is your 3s, this is 3p, and this is 3d. Okay, now let's check. It is 1 2 1 2 3 and 4 electrons. Okay, now sulfur in your again excited state, if we go, then we will see that what happens, the empty 3d orbitals which is there, no, they take part in bonding. Okay, when you go for bigger number of atoms other than the carbon, they form other orbitals also, they take part in bonding. Now see, check this one s will go, it will go here and here. If all these atoms, this after getting the energy from the system, this electron will go to this one, this electron will again go to the 3d orbital. So hence this is the one. So now check sp3d2. So what is the hybridization here? It is sp3d2. Okay, this is your sp3d2 molecule. And also check sf6 here. Okay, now the sigma bonds, it is 6 number of bonds. So this is actually hybridization is number is 6. So when the hybridization number is 6, it is sp3d2, and the shape will be octahedral. The shape will be octahedral. So how do we draw this one? We will draw this like this. See, this is your sulfur, this is your fluorine, 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 this is your fluorine, this fluorine. This will be the shape. Okay, see, this is the 3D picture of this. Is it not looking like an octagon? So that's why we say it to be octahedral. So the last molecule now we have is XeF4, that is xenon. Now what happens is that we will go for this one. Now xenon, we know what is the full atomic number is 54. So what is the last atomic valence shell? I will just write the valence electrons, that is your 5s2, 5p, 5p6. Okay, and your 5d0. So we will write its ground state. Ground state xenon, if we draw this one, okay, then it will be like this. Check. Sorry, we'll go for 5d. This is your 5p and this is your 5s. Okay, how many electrons are there? Here 2, here 6. 1 2 3 4 5. Sorry, 2p5. Okay, okay, so now what happens, xenon in excited state. Okay, excited state, what happens is that this is again your 5s, then you're again 5p, and then you're again d. Okay, so these two electrons, these three electrons will move to the 5d orbital. So it will be 1 2 3 4 5 6 7, 5 6 7. Why it is sorry, Sorry, I am not doing this one. I am doing IF7. This xenon one I will show in the in the next one with exception, not with this one. Okay. Now we are going for the true spatial arrangements, those molecules. When we will go for the exception one, that time we will be showing you xenon, XeF4. Okay. Now see here, what happens is that because here it is 7 fluorine atoms bonded to iodine. You know, iodine is nothing but a halogen which comes actually in the third third period. So it is greater in size. Okay. So 7, 1, 2, 3, 4, 5, 6, 7. So already we get 7. You can say 7 homes for fluorine when it is bonded. And so what is this? The hybridization here will be sp3d3. Okay, because you are taking all these into consideration, and hence its shape will be your pentagonal bipyramidal. Okay, pentagonal bipyramidal, this shape. Okay, and here there is no lone pair of electrons. Okay, so only iodine. So this way we find the diagram hybridization of different elements in inorganic chemistry. Now see how what will be the shape if it is like this. So the thing is like, it is like this. See, check. Okay, see, sorry, is it not looking like a pentagon? Okay, so if you go for 3D spatial arrangement, so it is looking like a pentagonal bipyramidal. Okay, so now let's summarize everything what we have learned. This BeCl2, we see how many number of bonding is around 2, no lone pair, so 0. Hybridization your sp, shape is linear. Okay, now this BeCl3. Okay, so how many bond, number of bonding, it is 3, again it is 0, again it is your sp2. Okay, so trigonal planar. When it is 4, see here 4, is it not number of sigma bonds 4, number of lone pair 0, again sp3. So this is tetrahedral, perfect tetrahedral. Now this is pf5, 5, this is 6, and this is 7. Again all lone pairs, there is no lone pair, so these are all 0. This is again your sp3d, this will be your sp3d2, and this is your sp3d3 whenever it is 7. Okay, so the shape again goes, this is your trigonal pyramid, I think this is trigonal bipyramidal. This is your octahedral, and this is your pentagonal bipyramidal. Bipyramidal. Okay, so this comes your perfect linear tetragonal, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral, pentagonal bipyramidal. So these are the shape, you know, these are the perfect shape. Okay, which does not have lone pair. Whenever there will be a lone pairs of lone pairs will be there, that time the shape will be, the hybridization will remain the same, whereas the shape will change, the spatial arrangement will be the same. This, it's actually the spatial arrangement, it will be the same, but whereas the geometrical shape will be different. We will go for that one. Okay, so we will go with that in the next video.